Okay, now we have to discuss about the chemical incompatibility. In last class, we have started about the chemical incompatibility, and then in last class we discussed about the introduction and up to precipitate yielding interactions. Then today we have to discuss about the examples for chemical incompatibilities which cause precipitate yielding and methods of their correction. Mainly there are 5 types of chemical incompatibilities. First one is alkaloidal incompatibility. Then they are subclassified into 5: alkaloidal salt with alkaline substance, then alkaloidal salt interaction with soluble iodides, alkaloidal salts with tannins, alkaloidal salts with salicylates, alkaloidal salts with soluble iodides and bromides. Then next incompatibility is soluble salicylates incompatibility. Then this incompatibility is again subclassified into 3. Soluble salicylates interact with the ferric salt, and soluble salicylates interact with the alkali bicarbonates. Then last one is soluble salicylates and benzoates with acids. Then third one is the soluble iodide incompatibility. They are again subclassified into 3. First one is oxidation of iodides with a ferric salt. Second one, oxidation of iodides with a potassium chloride. Third one, oxidation of iodides with a quinine sulfite. Then fourth one is chemical incompatibilities causing evolution of carbon dioxide gas. Then they are again classified into 3. They are sodium bicarbonate react with a soluble calcium or magnesium salt. Then bismuth subnitrate and sodium bicarbonate. Then borax with a sodium bicarbonate and glycerin. Then last one is the miscellaneous chemical incompatibility. They are soluble barbiturates with ammonium bromide, potassium chloride with oxidizable substances, incompatibility of emulsifying agents, color stability of dyes, incompatibilities of liquorized liquid extract. Okay. Then next one is, that is the first one is the alkaloidal incompatibility. Okay. There are 5 subclassification under alkaloidal incompatibility. First one is alkaloidal salts with alkaline substances. We know the alkaloids are weak bases which are insoluble in the water. Okay, the alkaloids are the weak bases which are insoluble in water, but their solubility, that is the solubility of alkaloids, can be increased by converting them into salt form. That is, alkaloidal salts are soluble in water. If these alkaloidal salts are dispensed with alkaline preparations, free alkaloid may precipitated. Example for alkaline preparations are strong solutions of ammonium acetate, aromatic spirit of ammonia, solution of ammonia, ammonium bicarbonate, sodium bicarbonate, etc. Okay, any of these alkaline preparation mixed with the alkaloidal salt, free alkaloid get precipitated. That is, alkaloidal salt react with alkaline substances and form alkaloidal base which get precipitated from the solution. Okay, but this when we are mixing alkaloidal salt and alkaline substances, all the time it will not be precipitated because all the alkaloids are slightly soluble in water. That is, this product, that is the alkaloidal base, that is the alkaloid, is slightly soluble in water. So if the alkaloid is prepared or produced in small quantity, they will not be precipitated. Okay, there will be not much quantity. Then for example, it is a formulation: strychnine hydrochloride solution 6 ml, aromatic spirit of ammonia 4 ml, water, QS 120 ml. Then we want to make a mixture. Here the problem is strychnine hydrochloride solution. It is an alkaloidal salt. Okay. Then aromatic spirit of ammonia is an alkaline substance. Okay. While these are mixing together, this alkaloidal salt and alkaline substance react together and the alkaloidal base get precipitated. Here strychnine is the alkaloidal base or free alkaloid. It get precipitated. This precipitate is diffusible precipitate. Then what method we can follow? We will follow method A, which we are discussed in last class. Okay. Then next one is alkaloidal salt with soluble iodides. In cough mixture, the potassium iodide is used as an expectorant. Expectorant means to expel the cough. So potassium iodide is used as an expectorant along with the tinctured ipecacuine and tinctured ipecac. This tinctured ipecac containing an alkaloid which called emetic. This emetic which induces the vomiting, and also it is used for amoebic infections. Okay, emetic is an alkaloid which is present in the ipecac, and it is used to induce vomiting and also used for amoebic infections. In this case, in case of ipecac, quantity of emetic is very low. That is, quantity of alkaloid is very low. So this emetic cannot be reacted with, or the amount of emetic is very low, so that there will be not much quantity to react with the potassium iodide to get precipitated as hydroiodides. If there is a large quantity of emetic, it will react with the potassium iodide and precipitate as the hydroiodides. Okay, in this case there is only very low quantity of alkaloid, so it will not react. So if we are using strychnine in case of the ipecac along with any soluble iodide, that is potassium iodide or any other soluble iodide, this strychnine contain high quantity of the alkaloid and form insoluble hydroiodide. Okay, this insoluble hydroiodide precipitate, these precipitates are diffusible. Okay, these precipitates are diffusible precipitates. So we can follow method A for dispensing the preparation. Then next one is alkaloidal salt with tannins. If the alkaloidal salt mixed with any drug containing tannins, they will react together and form tannates. These alkaloids form tannates. Then these tannates precipitated or separated as the diffusible precipitate. Okay, these tannates separated or form as the diffusible precipitate. So due to diffusible precipitate, we can follow method A for dispensing the formulation. Okay, then next one is alkaloidal salt with salicylates. When quinine compounds are combined with salicylates, it forms indiffusible precipitate of quinine salicylate. Okay, any quinine compound combined with salicylate, it will form indiffusible precipitate of quinine salicylate. So in case of indiffusible precipitate, we have to follow method B for dispensing the formulation. For example, quinine hydrochloride 0.12 gram, sodium salicylate 4 gram, water QS 100 ml. We want to make a mixture. Here the problem is quinine hydrochloride react with the sodium salicylate. Then it will form quinine salicylate. We know quinine salicylate is a indiffusible precipitate. So in case of indiffusible precipitate, we have to follow method B. Okay. Then next one is alkaloidal salts with soluble iodides and bromides. Alkaloids like strychnine, morphine, codeine, etc. react with soluble iodide or bromide when they are mixed together and form insoluble hydroiodides or hydrobromides. These are insoluble precipitate. So, we want to follow method A. While mixing the alkaloids like strychnine, morphine, codeine with the soluble iodide or bromides, insoluble hydroiodides or hydrobromide precipitate will be formed. So, we have to follow method A for their dispensing. For example, potassium iodide 1.5 gram, tincture of stramonium 8.5 ml, chloroform water QS 100 ml. Here the problem is tincture stramonium. This tincture stramonium contains solanaceous alkaloid. This solanaceous alkaloid react with the potassium iodide, then form hydroiodide. These hydroiodides are diffusible precipitate. So, we can follow method A for dispensing the formulation. Okay. These are about the alkaloidal incompatibility. Then next one is the soluble salicylate incompatibility. Under the soluble salicylate incompatibility, there are three types. First one is soluble salicylate with ferric salt. This soluble salicylate react with ferric salt and form ferric salicylate. This ferric salicylate is an indiffusible precipitate. Indiffusible precipitate. So we can follow method B for their dispensing. Okay. For example, ferric chloride solution 2 ml, sodium salicylate 3 gram, water QS 90 ml. We want to make a mixture. Here the problem is ferric chloride react with sodium salicylate and form ferric salicylate. This ferric salicylate is an indiffusible precipitate. So we want to follow method B for their dispensing. So in one way we can follow method B. Otherwise, other remedy for this problem is in presence of sodium bicarbonate. If we are adding a sodium bicarbonate to this formulation, that is in presence of sodium bicarbonate, the precipitates of ferric salicylate remain soluble. That is the ferric salicylate. If we are adding the sodium bicarbonate to this formulation, the formed ferric salicylate become soluble. So, will be form a clear mixture. Okay. That is ferric chloride solution 2 ml, sodium salicylate 3 gram, sodium bicarbonate 8 gram, water 90 ml. Here we can add sodium bicarbonate 8 gram to this formulation, so that in presence of sodium bicarbonate, the formed precipitate of ferric salicylate become soluble and clear mixture will be formed. Then how we can dispense or prepare this formulation? First of all, we want to weigh sodium salicylate and sodium bicarbonate. Then take 70 ml of water. Then this is dissolved, sodium salicylate and sodium bicarbonate is dissolved in 70 ml of the water. Here we require 90 ml, that is we can take 3 by 4th of the water, 70 ml of water. To this add sodium salicylate and sodium bicarbonate and dissolve them. Then add ferric chloride solution. Okay, then while we are adding ferric chloride solution, effervescence will be produced. When effervescence ceased, when effervescence stopped, filter through the cotton wool, then it is transferred into measuring cylinder and make up to the volume 90 ml with the water. Okay. Then next one is the soluble salicylates with the alkali bicarbonates. If sodium salicylate is administered orally into the stomach, the sodium salicylate react with the hydrochloride which is present in the stomach. So while reacting the sodium salicylate and hydrochloric acid, salicylic acid get precipitated. Okay, salicylic acid get precipitated. This precipitate cause, or this salicylic acid cause irritation and pain in the stomach. This HCl is present in the stomach. Okay. Then, so to avoid this irritation and pain in stomach, while we are prescribing the sodium salicylate, we have to prescribe 2 times the sodium bicarbonate along with the sodium salicylate. So we can so this sodium bicarbonate can neutralize the acidity or HCl of the HCl which are present in the stomach. Okay, while we are prescribing sodium salicylate, prescribe 2 times of the sodium bicarbonate so that the sodium bicarbonate neutralize the acidity or HCl which are present in the stomach, so that no precipitate will be produced, so that sodium there will be no HCl for reacting with the sodium salicylate and no salicylic acid will be formed, that is there will be no precipitate. Okay, then if we are dispensing the sodium salicylate in solution form along with the sodium bicarbonate, the mixture will absorb the oxygen from atmosphere. That is, if we are prescribing the sodium salicylate in the solution form along with the sodium bicarbonate, this mixture, the mixture of sodium salicylate and sodium bicarbonate will absorb oxygen from the atmosphere and become reddish brown color. This formation of reddish brown color does not affect the therapeutic efficacy of the mixture. Okay, it does not affect the therapeutic efficacy and it is not an incompatibility, and it should not affect the shelf life of the product. But there is a problem while it is converting it into reddish brown color, that is it make confusion in the patients. Okay, this conversion into reddish brown color does not affect any therapeutic efficacy of the mixture, but it may cause confusion in the patients. Okay, so patient compliance is important in case of medicines, so we want to avoid this color change. So we can add either an antioxidant or an coloring agent. Okay, if we are adding antioxidant, the oxidation we can prevent. Okay, the mixture absorb oxygen from the atmosphere, and here oxidation takes place. So by adding antioxidant we can prevent the oxidation reaction. So for example, so that the reddish brown color change will not be produced. Okay, for example for antioxidant is sodium metabisulfate, which is used in the concentration of 0.1% weight per volume. Or we can add any coloring agent, any reddish brown coloring agent. For example, liquid extract of licorice. Okay, so that the patient cannot be able to identify the color change. Then for example, sodium salicylate 4 gram, sodium bicarbonate 8 gram, chloroform water QS 120 ml. Then here the problem is that the sodium salicylate and sodium bicarbonate absorbs the oxygen from atmosphere and become reddish brown color. So here the remedy or solution for this problem is that we can add sodium metabisulfate 0.08 gram. Then how we can prepare the formulation? First of all, we have to take sodium salicylate and sodium bicarbonate. Then it is dissolved in the 90 ml of water, that is 3/4 of the chloroform water. First of all, accurately weigh sodium salicylate and sodium bicarbonate. Then it is dissolved in 3/4 of the chloroform water. Then to this mixture add sodium metabisulfate, that is the antioxidant, and then dissolve it. Then filter through filter paper. Then make up the volume with the remaining amount of chloroform water. Okay. Then last one is sodium salicylate and benzoates with the acids. Most of the acids and acid syrups, example for acid syrup is lemon syrup. We know the main ingredient of lemon is citric acid. So lemon syrup contain the citric acid. So this is acidic in nature. That is, it is acid syrup. Most of the acids and acid syrup decompose the sodium salicylate and sodium benzoate. Okay, while we are mixing the acids or acid syrups along with the sodium salicylate or sodium benzoate, this the decomposition reaction occur in between the acids and acid syrups and sodium salicylates or sodium benzoate. Okay, by decomposition it will form the precipitates of salicylic acid. If the acid or acid syrup react with the sodium salicylate, then salicylic acid will form. If the acid or acid syrup mixed with the sodium benzoate, then benzoic acid will form. Okay, that is form the precipitates of salicylic acid or benzoic acid. These precipitates are indiffusible precipitate. In case of indiffusible precipitate, we can follow method B for the preparation. Okay. Then example, sodium salicylate 3 gram, syrup of lemon 15 ml, water QS 60 ml. We have to prepare mixture. Here the problem is syrup of lemon is a acid syrup which contain citric acid. Okay, it will react with sodium salicylate and precipitate salicylic acid. By the reaction between syrup of lemon, that is citric acid, and sodium salicylate, salicylic acid will be formed. This salicylic acid is separated as indiffusible precipitate. In case of indiffusible precipitate, we can follow method B for dispensing. This is one of the remedy. Another remedy is that we can replace the syrup of lemon with a simple syrup and tincture of lemon. Okay, here syrup of lemon is used as the flavoring agent. So it will not have any therapeutic effect or therapeutic value. So by replacement of syrup of lemon with a simple syrup and tincture of lemon will not affect any therapeutic value. Okay, the lemon syrup is used as the flavoring agent, so its replacement with a simple syrup and tincture of lemon does not affect the therapeutic value of the mixture. Okay, that's all about the two types of chemical incompatibilities. Then other three types we can discuss in next class. That's all.